Well, good morning, everyone. My name is Bruce Belzowski. I'm the Managing Director of the Automotive Futures Group here in Ann Arbor, Michigan. And today we're hosting our 14th annual Future of Automotive IT Conference here at the U of M. But we also have a lot of our people online today, and this is why we're doing the YouTube live streaming. So thank everyone for attending and for both in person and online. Looking forward to a good discussion today. Before we get started on the topic of the day, I want to introduce Gene Mage, who's from the U of M Ross Business School Executive Education Program. He's going to give a quick overview of the work that they're doing. Welcome, Gene.
All right, thank you very much, Bruce, and welcome everybody, whether you're here in the room or joining us by the YouTube stream. Really delighted that you're here. On behalf of the University of Michigan, I want to give you a warm welcome. So when people ask me about the University of Michigan and people who aren't in the university, I like to share some fun facts. Of course, we have 3,000 faculty and 21 Nobel laureates, a big operating budget. But one of the things I'm most proud of is the investment that the university makes in R&D. And that $1.7 billion in the last year went to work on some of the world's toughest challenges. Some of the things you'll be talking about today, the things that improve the quality of people's lives, whether that's their health or environmental sustainability, all of those things that you hear about, those wicked problems, that budget goes to work on. So you get to benefit from some of that today. We have a big alumni base. I know you know that, and lots of sports accolades, about 50,000 students this year. And we've been consistently ranked the #1 public research university in America. Over 100 graduate programs in the top 10. So I think you'll agree with me, the University of Michigan is a very special place. I mean, what other school can claim to have both Tom Brady and Darth Vader as alumni? And lots of other famous alumni too, whether it's astronauts or presidents or famous personalities. Any field of endeavor, any place in the world, you will find Michigan grads. You walk down the street in Shanghai and you wear your shirt, somebody will say, "Go Blue." Michigan Ross is the business school within the University of Michigan. Also, one of the largest programs, business programs, and top-ranked programs in the world. More than 4,000 students this year. More than 200 faculty work in business program. So within that, we have what we call executive education, which is the things that probably are relevant to you and your organizations. So we do the non-degree stuff. So basically people who are out in their careers, they want to improve their careers and improve their companies, we partner with them. Whether an individual, if you're just a person who says, hey, I want to take a class to advance my career, we will partner you up with other people from other companies in the open program classes and customize solutions as well for companies who want to work on specific problems that they have. And we deliver in all different means, whether live, virtual, face-to-face, whatever it is. Recently ranked #1 provider in North America. So some topics that we do, just a selection here, like digital transformation or influence, team leadership or executive leadership, or even things like strategic decision-making, you can come and join a class. So if you go to our website, we keep that schedule up to date all the time. So you can see the whole list, you can see when they are, and you can sign up or recommend somebody from your team who'd like to join a class. We also do customized programs. So, and I know some of the member organizations here take advantage of that, whether you just have a small team, a department, or you have a big unit, a whole operation, we can come in and do a customized program to develop the employees that you have. So with that, if you want to know more, I'd encourage you to go to our website. And also there's a self-assessment you can try out. So that will give you some feedback on yourself as a leader. It will give you some feedback on your learning goals, and it gives you a chance to assess your organization as well. So with that, I just want to give you a warm Michigan welcome. We're so happy that you're here. Have a great day. Enjoy the conference.
Thank you, Gene. Piyush Karkare from Siemens Automotive.
All right. Hey, thanks, Bruce, for my introduction. Little bit of just quick background from my side. I've mostly been in automotive industry about 30 plus years now. Most of it at Ford Motor Company before I joined Siemens about 6 years ago, working in their electrical systems, and then joined their in-vehicle systems, and then joined Siemens to take care of more solutions that we can cater to the automotive industry in general. So when Bruce kind of reached out to me, it was very interesting to talk about the future of automotive industry in general and what's happening here. So I put together this deck to talk about what's in the future and how the industry is kind of catering to it. Given what's happening in the industry today, all of things about autonomous or ADAS systems and electrification, connected, and all the smart mobility aspects of it, like I'm showing here on the slide. I feel two things that are sort of common in all of these sort of, let me call them mega trends, if you want to call that. One is the vehicle itself is not a closed system anymore. A lot of consideration happens within the vehicle and what's outside of the vehicle. So that's one. And second, a lot of it is being now enabled by software. So if you look at autonomous or ADAS systems, all the safety features, electrification in terms of the battery management and sort of the range optimization and performance of the vehicles, connected, obviously, how everything gets connected to the vehicle from the connector, from the vehicle, and then how overall mobility as a service or transportation as a service and all of that is getting connected. So all of that, some common theme in there is obviously a software. So given that, the industry is taking a lot of effort in understanding and how we want to move to these new product development paradigms in considering vehicles as systems, and those systems being not just vehicle itself and what's around the vehicle as well. So that was sort of the theme that I had in mind to kind of present today. So I was looking at what's going on in the industry. Let me just move this over here. If you look at just about 10 years ago, it was all about going from point A to point B. All the vehicles, like I said, were more about, it was about more of the vehicle itself, as to what we want to do with the vehicle. How do we optimize the engineering within the vehicle? In the last 10 some years, what's happened is it has kind of exploded in terms of the engineering complexity and how do we make vehicle as our transportation or mobility as an accessible thing, right? You want to go from point A to point B, whether it's the first mile, last mile thing, or you are going long distances, or even getting goods moved around. I see in Ann Arbor, these small thingies where delivering pizzas or delivering food or whatever. Amazon's talking about these drone deliveries, and autonomous trucks are on the horizon as well. So I see that a lot of things have happened, and we have moved on from just going from point A to point B to more about how do you make all these things accessible to us as humans. So it is more move more towards that human-centric innovation, if you want to call that. But if you look at the overall, I mean, what's happened is, as you engineer all of these different things, you can take any one of these, and the complexity in these products is enormous. And as I said, it's not just for that vehicle, but how that vehicle interacts with the surrounding around it. So if you look at the complexity, the industry is obviously paying a heavy toll on the product complexity itself, as well as the traditional organizational complexity that we have had, in terms of how we are organized within a company or within the ecosystem, if you will, between the OEMs and suppliers, and also the processes that we use. So all of these things are highly complex now and changing as we cater to this level of complexity that's coming in from the market side of it. There were some surveys around, what is that doing to our industry? I mean, these are some of the metrics that I found about 53% more resources are being needed. A lot of companies are kind of losing or missing their targets in terms of product initiatives and product objectives. It takes a lot more experience in delays. They're experiencing delays in manufacturing, and as a lot of software goes into these products, there's a lot of changes happening after the product is launched. So a lot of issues that you see nowadays are mostly because of software, or it's a good and bad thing, because because it's software, it can be fixed easily and you don't have to wear a lot of hardware costs or hardware replacement costs. It can be replaced with various software updates and things like that. But in general, the industry is having issues with overall product integrations in terms of the development time that it takes. And talking about time, is when you're building these products, as you go through the overall process from concept all the way to the operation of the vehicles outside, this concept phase is a very critical piece. If you don't do this right, fixing issues later on becomes an exponential cost, because as you lock down your concepts, basically locking down a lot of costs with it. So there's an actual cost of actually doing this, but there's a committed cost because you are committing to a certain aspect, a certain way of doing a certain feature or functions and things like that. So this concept phase has become a very critical phase. So that if you don't do this right, there's a lot of issues happening later on. So there's a lot of focus being brought over in this initial phase as to how do we do this right? What are the steps that we can take from a processes standpoint to do this concept phase in a rock solid way? So I'll be talking a little bit more about this concept phase itself, but also how it relates to the overall product engineering per se as well. So in general, when you think about this concept phase, the industry is kind of moving towards this model-based systems engineering. Now, systems engineering as a methodology has always been there. I mean, I've known electrical system engineers for a very long time. But what's now changing is giving it a more model-based approach to it. Now, what I mean by that is, in general, the systems engineering, when you were doing this thing, a lot of authors creating a lot of documentation, whether it's in Excel or PowerPoints or Visio diagrams and whatnot, were created to define the systems, to propagate the intent of the systems and things like that. And they possibly were stored in a lot of different databases as well. So as consumers of that information, the engineers who were consuming that information in a document-centric view, they had to go to many different places to get it, and hopefully they're getting the right information when you're getting to the right database, and whether it was in Teams or some sort of SharePoints or even PLM systems. But the issue always was, am I looking at the right data, right document? Is this the right granularity that I need, and more importantly, is it at the right fidelity that I need it? So all these consumer issues were there with this document-centric view of the system engineering documents. Now, moving towards a model-based one, everybody's looking at the same model. The model itself would provide different views of whether you're looking at from a state machine perspective, or whether you're looking from feature function decomposition perspective, whether it's a logical entity, irrespective of how you can implement it, or physical implementations of it. All of those aspects of a system would be contained in a system model. So that's what became more of a model-based approach. As the same, all the authors kind of authoring that, and consumers actually looking at the same thing, possibly even at the same database that model is stored and shared across. Why it is needed? Well, I mean, think of this vehicle, for example, the Mercedes EQS. This vehicle is actually a real thing. You can buy this vehicle. I mean, if you look at the complexity in that vehicle, underneath these covers enormous amount of complexity. But as a customer, when I want to buy this, I want to touch and do these kinds of features in this, I want it delivered very simplistically. if I have to, touch 5 things to get to somewhere on these dashboards, all that is the complexity that I don't need as a customer of this vehicle. So a lot of this complexity that goes behind the scene has to be delivered with simplicity. And that comes at a pace of innovation that is unprecedented, right? That is why you need methods like system-based model-based systems engineering. So I mean, now it has become a more of a necessity than a luxury that, okay, should I do it or not do it? I think that point has passed about 5 years ago, if not earlier. So I think that's why. And a lot of times, I do get asked, what MBSE tool do you use? So I wanted to, get that off the table. That MBSE is not a tool. It is something that the engineers do in their processes. That it's a method, it's a formal way of doing things. It is enabled by certain processes and enabled by certain tools. And there may be, one or more tools required to do what they need to do. So this just kind of taking that off the table, that it's not a tool, it's more of a thing that the engineers do. The challenge of doing this today is traditionally we have been sort of siloed in the way we do things, or in the organizations that we have around in the companies. The systems engineer develops some things, then it gets over the wall, and then the software architects do something, the e-architects do something. And as you go between these walls, either the data gets lost, or more often, things that the system engineers do may not be even understood by the other side of the wall. There was an actual case. I think it was one of the Mars rovers, where in a detailed system engineering model was created. A system model was created of that rover, but when the next guys took it, they couldn't understand any of it. I mean, it was way too complex. Too much information was put into that, and they just had to redo their work as they started to do the electrical systems and software systems for that rover. So those kind of things happen. So how do you do this, in a way that is consumable by the downstream, is simple enough to detail as much as you want at a system of systems level. And again, when I say system of systems, because the vehicle itself is the system itself is more than just a vehicle, right? So you have a vehicle and all the surroundings around it. That's why I kind of say a system of systems kind of way. So be able to define that simplistically and be able to consume it. That's the biggest challenge I feel, to communicate the system models to all the stakeholders that are needed. So that's what we want to actually solve. And like I said before, it is becoming more of a human-centric innovation now, where all those things, that whether you call it micromobility or high-speed or autonomous systems and all that, everything needs to be considered from a perspective of, is it what really people need? Is it technically possible? And does it make sense from a business perspective? So these 3 things are the key holy grail of human-centered innovation, that when you do model-based system engineering, you always have to be cognizant about these 3 things. In how you build your models, do you understand what the need is, whether it's feasible, you're doing all the feasibility aspects of it up front, and obviously, does it make sense from a business standpoint? Can we make money off of it? Things like that. So the approach that I'm going to talk about is, how do you do this needs analysis upfront? Once you have an understanding of what's needed by the system, how do you do the concept exploration? Many different ways of implementing those needs or those requirements, and then decision on how, which specific way or which specific implementation you're going to go forward with. And that's what leads into more detailed product engineering. And overall, that's what squeezes your time and effort to do things. As I said in the front, this concept design phase is very important, because you're locking down an enormous amount of cost when you do this. When I talk about needs analysis, it's more about what features you're going to have on your product, what are the variability, what are dependencies of those features with other features that might be there on your vehicles, what's the reusability aspects of it, requirements elicitation. I was at an INCOSI conference a month or so ago. Well, a very interesting statement someone made there is these requirements are nothing but agreements on your needs. So what the system needs, when you agree on those system needs, those become the requirements. So understanding those needs, converting them to what you agree on and what you're going to implement as requirements, very important to do that. This features and scenario definitions, this is another one that's happening in the industry, where it's not just the requirements or the textual or model-based requirements that are necessary to define these systems. It's also the real-world scenarios, how the vehicle shall behave in the real world. So you want to capture some real-world scenarios by actually driving some existing vehicles around and see as to how the vehicle should be reacting to certain scenarios. When someone comes all of a sudden in front of the vehicle, or someone crosses the vehicle, or the vehicle has to react to some anomalies and things like that. So these real world situations, how do you capture them and use that as an understanding of the system that you're trying to define. The next is the concept exploration, where you start to do the trade-offs. You try to understand as to what are the different ways I can implement this system that I now understand, and start to decompose that feature or that system into meaningful functionalities, interfaces between those functions, and then doing some preliminary understanding of how those implementations will be. Are they going to be technically feasible? Are they viable from a business standpoint? And once you do that upfront, then you start to lock down. Then you start to do your architectural selections and baselining of all the architectures and interfaces and requirements. And that's what cascades into the respective domains with the mechanical, electrical software. And if you notice, I had this, the simulation piece down here as a continuous thing, all the way from when you were starting to understand the system, even from that point all the way to the trade-off studies and concept definition. The simulation piece is what makes sure that whatever you're considering is what is technically feasible aspect of it. So you're doing it upfront before you go into detailed engineering with the respective domains. So another thing that is happening is this whole agile aspect of it. Now, agile used to be more of a software thing. Now companies have adopted that at a product level. So everyone wants to do product engineering or product development in a very agile way. And there are some frameworks like the scaled agile framework, safe agile frameworks that allow us to understand as to how we can adopt these agile methodologies at a product definition level or product development level. So I kind of use that as a construct behind to understand how we can do systems engineering in this very agile way. So first and foremost, like I was saying before, understanding the features, what's existing, what are the dependencies, which features are mandatory, which are optional, what's getting modified, what's new based on what portfolio backlogs you would have, based on the portfolio vision and the themes that your company might have. So this is sort of that agile safe methodology coming in, or aspects of it coming in, to understand the voice of the customer as to what we really want to have in our products, and does it make sense to have them in our product, what kind of combinations that we need to have in our products. Then you have the requirements elicitation to understand the needs, capture the requirements, whether it's model-based requirements or just textual requirements. Either way, you need to have some measurable parameters around how you're going to verify those parameters for those requirements. So those parameters going to go alongside with those requirements. And then these scenarios, we are capturing these scenarios, monitoring the vehicles, analyzing them, understanding what are the niche scenarios that you really have to worry about. There could be hundreds and thousands of these scenarios being captured. Be able to catalog them, be able to query them, be able to do some AI algorithms on it to understand what are the niche, unknown and unsafe situations in these hundreds and thousands of scenarios. What I really have to worry about. So those are the kind of things, and then you use those to do, design and exploration of those scenarios that you select, or niche scenarios that you select, and maybe even put some noise factors on it. What will happen if it was raining, or there was sleet, or there was some sensor soiling happening, and the camera doesn't see. Will the radar see it? And things like that. So you start to design some of these scenarios on your own using the existing scenarios that you capture, and then use that to do your verification validation when you have a system implementation done. So you do all this to understand, first of all, what the system is supposed to be doing. You do that operation analysis, you do the function analysis as to how you start to implement that. And this is where software starts to come in. This is at this early age of concept definitions, of concept exploration. This is when you start to understand, how will I do this with software? How do I create differentiation of my product with software? And as you consider software, you also start to consider your hardware aspects of it. Upfront, even in this stage here, as to, is my hardware going to be enough? I have a certain level of CPUs or ECUs on my vehicles today. Are they going to be enough if I implement these 5 functions now, using 5 different cameras and 2 radars and lidars and whatnot? Is the processor going to be enough? Is the bandwidth on the network process, is that going to be enough? So you do that early analysis of your implementation. Start to consider your safety and security aspects here as well, right? In this stage, when there is no actual software being written, you're just assuming things. I'm going to do these 5 functions in software. These things are going to be implemented on that hardware. I understand if that hardware is going to be enough, and that's what you start to decompose your features or your systems into these functional allocations of how you're going to do this. And I use another construct from the software side of it, which is the service-oriented architecture, but at a product level. Again, all these functions be considered as services. I need to detect a vehicle ahead of me. Okay, that's a service. If you give me inputs around the camera, I can tell you, what kind of vehicle is out there, or if there is a vehicle out there. So all these functions can be decomposed as services, and then allocated with hardware or software, or hardware or software only, and have the traceability to these requirements up here. This is what we use to do those trade-off studies early on with these agile sprints. System engineers kind of working with software teams and hardware teams to understand the optimizations that are needed at a multi-domain level with 1D analysis or hardware readiness. Upfront, analyzing, is my hardware enough? We can go all the way down to a chip design. Even if the chip is not ready yet, we can do some studies at the design level of the SoCs and chips and I can run some algorithms that I'm assuming upfront here, so that we can do those kind of things. Use models to create based on these requirements and these functions that are needed, and use these scenarios to test them, whether that scenario will actually can be executed with the algorithm that we're thinking about. So once you lock all these things down, that's when you start to decompose that into the respective domains, whether it's mechanical or software or electrical. So now all of these engineering domains are now totally connected with this concept creation that you did upfront. So because you did a lot of work here upfront, that concept phase is now rock solid. And all you now have to do is that detailed product engineering, where you're defining as to whether you're going to have a signal at a certain network bus based on the requirements of the system. That detailed work you do up here. But upfront, you already decided that there is going to be an interface for this function to talk to another function. That interface eventually became a CAN signal or Ethernet communication, and that's what you detail down in the software domain and whatnot. So you wrap that down with the digital thread underneath that helps you with the overall traceability. And when I say traceability, is not just the traceability from a data perspective as to what changed and who changed it kind of thing, but more so why it was changed. If something was changed, you have the traceability of why it was changed. All of these stakeholders that are involved in this concept definition and the detailed work, they all collaborate from that one single system model of that feature, which is decomposed and locked down. And that allows us to do the reuse as well, the functionality of these services that you need. So that's what allows you to do, the digital threads allows you to do to enable this traceability, collaboration, and reuse, and bring the information all the way from even implemented features back into how you're doing these kind of decomposition and things like that. So that's the overall sort of agile system engineering that is being adopted. Just to kind of circle back on the overall picture, this is how the needs analysis and concept exploration and concept definition helps engineers to kind of define these system of systems now that you and leverage that complexity that is coming into the industry as a differentiator and not a challenge. So that's how you do this. And beyond this phase, I took this from the book, which kind of really nails down as to how this needs analysis, concept of exploration, and concept definition kind of helps the overall product development and all the way up to production, even after, like how you do OTAs and things like that. Because you need to have this concept phase really rock solid to even enable OTA, so that the dependencies of hardware, what is available to update and what's not, and where to fix what to fix, and things like that. So here's an example. I'm going to run this video. Let me see if I can run that video real quick. This is how the actual tools look like. There's a lot of stuff happening here. You're doing all your concept phase up here. You're relating that requirements. You are basically doing the trade-off studies up front. You're trying to analyze. You're making some assumptions in the system model that I have 5 cameras connected to a chip over Ethernet, and you make an assumption in the system model that this much data is going to be transmitted over that interface. Now you can take that information as parameterized information down to the tools that are doing bandwidth studies, bandwidth analysis, and you can understand as to how much bandwidth will be consumed if you do 5 cameras over Ethernet. And you might find out that, well, it's going to consume 80% of the bandwidth that's available to you. And there might be a requirement saying, well, you cannot have more than a certain threshold for the bandwidth. As soon as this data comes back, that requirement automatically goes to red, saying you violated that requirement. Same thing happening for maybe even power consumption. So if you add 5 cameras, is there enough juice on the vehicle? Things like that. You can start to analyze and start to create some workflows to have the detail engineers kind of say, well, tell me right now, because I'm doing this concept phase study, tell me right now if there is enough power on the vehicle or not. Controls guys, the software controls guys, algorithm guys, they can tell you how much processing needs to be done, and what's kind of a timeline, what the state machines kind of stuff happening to consider upfront. And also some mechanical issues. If you're adding ADAS features or you're adding autonomous features, if you add, let's say, the duty cycles to certain parts of the vehicle, in this case, a steering knuckle, will the steering knuckle take on additional duty cycles? If not, well, we can highlight that, and we can start to redesign the steering knuckle in generative mechanical design to understand how we can take care of the duty cycles, the more duty cycles, and then positioning of cameras and things like that. Another thing which is we use our pre-scan tools to understand where these cameras can be positioned, what's the optimized location of the cameras, given scenarios that we want to bring in and see as to what the camera sees, and we mask those scenarios onto those cameras and see if the algorithms are going to actually react to those scenarios in the way that we are assuming things are going to happen. So you can do all these things up front. So that's sort of the overall thing. But as I think Bruce talked about, implementing these things, take a lot of effort, right? So we recommend, obviously, we partner with our customers we start small, understanding, what do they have, what are the people doing right now, what processes do they have, what tools do they have, start small and then start to realize some quick successes in terms of what can we do with existing infrastructure that we have, in existing people and processes that we have, and then start to prioritize how we're going to take it to the next step of this digital transformation. And from that on, we build and scale up. And it's not just fluff in the air. I mean, these companies like Hyundai and Lockheed Martin and Northrop, and these are all companies who are actually now taking that step of reinventing their processes, reinventing their business models. Like Hyundai Motor, for example, they're calling themselves a mobility company now, that they want to redo everything as to, not just vehicles, but transportation and mobility as such. So what tools are going to be needed to do that? So they're looking at everything on their portfolio. And same thing with Lockheed, trying to squeeze that the product development and have it done this concept phase real well, and phase it down into their detailed engineering aspects. So that's mainly what I had, Bruce, from my perspective. We deliver that from a Siemens perspective with this accelerator, which basically all the tools that you need in one sort of environment, including all your electronics, electrical, mechanical, and PLM, and all those things built into one accelerator environment, also available on the cloud now. So that's how we deliver it, and we work with our partners, our customers. We call them partners, in terms of giving them the technology, giving them the people, even with our expertise that we have put in house and understanding of the processes. So that's mainly from my side of it. Any questions? Welcome to get it.
Thank you, Piyush. Lots of complexity here. Lots of complexity, and kind of like dealing with the complexity, right?
Yep.
So a couple of questions for you. When you're looking at the differences between actually in the processes that you're describing, are there differences between systems that, for example, are managing EVs and ADAS systems versus programs that are like consumer facing inside the vehicle? Do you see any differences in how those play out within your system?
I wouldn't say differences, but they're more of the level of considerations, if you will, level of considerations as it comes to more customer facing. There's a lot of consideration of safety kind of thing. Safety is not something that you consider. Safety is the thing that you consider. I think later on we talk more about security as well in the conference. I mean, those kind of things are upfront being considered, more so than some things like ADAS, for example. ADAS is all about safety, right? Electrification, again, the game is more about optimizing performance, optimizing range, optimizing comfort. So that's what you're doing with. So I think it's not different, but it's just a consideration thing as to what you have to consider from a system perspective. And again, understanding of the system, understanding the need as to what really people in need. Technologically, is it possible, and from a business standpoint, is it really worth doing it? So depending on which one you're talking about, whether it's a customer thing that you mentioned, business viability may be a primary thing. Can we make money off of it? Is it going to be safe? Is it going to be secure? So things like that, I would say.
Okay. When you look at the companies that you guys work with, how far along are they in this transition from a more, they've always been working with dealing with issues along the process for developing vehicles, but this kind of changes things. How far along are they in making this transition?
I think, there is a various level of maturities everybody's at, some more than others. Hyundai, for example, they're now focused on MBSE. How do they, bring that in? And like I said, I mean, systems engineering is not something new that, they've been doing that, but they have been doing that in pockets. So now the question is, how do we do that as a cohesive thing, as a comprehensive thing, and give it more and more model-based approach to it, and more so the fidelity of the models, like how these models are defined. The way we Siemens talk about it is, how do you do this simplistically that everybody can understand, right? You don't want to have a model that is so complex that you build that only the people who build it understand it, right? So those kind of things are coming in. So it was not about, can I build a model? Have they been building the models? Yeah, they have been building the models, but they haven't having issues about, the people who, there are 20, high-level system engineers that make it and they understand it. But rest of the world in the company, I need to do my own to understand what the system's trying to do, and I'll make my own. I'll maybe understand 50% of what you did, and I'll make my own. So those are the kind of things that are changing. And these methodologies like Arcadia, things like that. And then the new things that are coming in with SysML v2 can allow us to have more collaboration and more sharing of information in a very sort of machine readable way. So that's what's changing. That's what's coming in.
Now, when you look at the implementation of the new systems that you're talking about, do you see different adaptations globally?
Yeah. I think like I said, like Hyundai, they are moving on with it. Japan is slightly right behind them, I would say. They're on for it. In US, we have been doing stuff. I mean, I remember back at Ford we were doing this about 5-10 years ago, and we started doing those kind of things. So yeah, I mean, globally there is level of differences, but what I said, in general, everybody wants to move towards this way of doing things now, and not because they want to, but more so because they have to. These kind of systems are now so complex that without understanding them, and not only understanding them, but be able to communicate them, it's a necessity now. So it is not something. I mean, when I attended in COSI, it was like a global thing, right? It was coming in all different people from different industries as well as different places around the globe, and that was a common thing there, that these systems are getting complex. They are not just technical anymore. There is social aspect of it, this human centered innovation aspect of it, as to how these machines talk to or interact with humans. That is a very complex thing to understand. So I think because of that, this whole thing is becoming a necessity, and everybody understands. Everybody's trying to cope up with it. So what do we do next with it?
Is this technology that you're talking about, or this process that you're talking about, something that's that the suppliers tap into within within the OEM, or is it
definitely
only OEM only?
Oh, no. Suppliers and OEMs, actually more so suppliers, because as these what I call systems, or we call them features, as a system, a lot of suppliers get involved in one feature. If you talk about, for example, back in the day when I was talking about these features, if you hit that stop button in your car, about 20 different ECUs wake up to do something, meaning potentially 20 different suppliers have to do something about that one feature as you touch the button. So be able to communicate that to suppliers, and then suppliers be able to collaborate back into that feature. That's what needs to be enabled with these kinds of processes.
Very interesting. Kara, do you have any questions online? No? Questions from the audience?
One of the things you show and explain was the difficulty of keeping models reusable across departments and people. How do you balance ease of use for humans and that graphical reusability with the importance of automation and scripts and being able to commit to Git or integrate into a DevOps through something? Can you talk a little bit about that balance? methods
yeah,
you have?
sure. So I mean, the way we are doing this from Siemens standpoint is there's an enormous amount of focus on those kinds of things where how do we make these models shareable, whether you're saving it with Git or whether you're sharing it with some other mechanism. Will you be able to sort of carve out a portion of the system and collaborate with your supplier with that portion of the system? Make a sort of supplier package, if you will. Like I said, you have these system assumptions that you're doing, be able to parameterize them, be able to assign or allocate requirements around it, and say, all right, here's the package. I'm going to give it to you as a supplier. You come back to me as to what you're going to do about that particular component or a set of functions, and then come back to me with your implementations, and I should be able to import that back. So those are the kind of things that we are fully focused on, totally focused on. And another thing that's happening is whole from this OMG side of it, where system or V2, making these things more, let's say, machine readable. So I should be able to incorporate that with different tools, be able to consume it. So if I'm making it in Rhapsody or making it in Capella that we use or some other tool, and taking it down to electrical systems to be able to consume that information directly, add that even down at that component level, having all those relationships to parameters and requirements and models. That is what we are enabling.
Very good. Other questions? I got another one.
Yeah, so I think you already mentioned that with all of these changes taking place in the way systems are designed, it's going to increase the time. I think you mentioned 30 to 50%.
Yeah.
And I thought it might be like 100% increase. So in terms of actual number of years, so what is your assessment that it is going to increase? Let's say if it was taking 2 years to design, will it be taking now 3 years? And if that is the case, where are the companies like OEMs or even the tier ones in terms of their next generation designs? This is one question I have.
Overall product development time.
Yes.
Yeah, I think obviously the product development time has probably more parameters that drive that from a timing standpoint than just this sort of the concept phase or the MBSE side of it. But in general, what I see is how everyone is trying to do is how do I commonize across different vehicle product platforms. So it's not just one single vehicle that they're trying to do it in less time, but it's more of how do they commonize, how do they reuse a lot of these functionality, a lot of these functions, and I'm starting to call it more services. So as you go and change your paradigms around thinking about everything as a service, that drives companies to think standardization, that drives reuse, right? So everybody wants to leverage things like Amazon Automotive, where they're trying to give all the kind of services, so they don't have to, as OEMs, suppliers, they don't have to create voice recognition, for example. I mean, it's a service. You consume that, you don't have to reinvent that anymore, right? So that saves you a lot of engineering cost and time. So things like that are happening. All of these, I call it the hyperscalers, like Google's and the Amazons and Microsofts, the guys coming into automotive industry just for that piece of the pie, right? And it's a big deal for all OEMs and suppliers. When we talk to Bosch or others, they want to leverage that. And I don't want to invent things. I just reuse the service and make things faster. So in general, I think that is what I see as trend. Whether that squeezes the 33-month time to 30 months or even less, I don't know. But what is real is the software time, the software update piece of it, right? And we call the software-defined vehicles kind of thing, right, for nothing. But that software piece is what is squeezing really, really, really fast. I mean, I've heard total new piece of software features coming in 10 weeks of times. So you have an existing feature, and you build a new feature on top of that existing feature. Within 10 weeks, you start and you deliver it with OTA to the vehicles. I mean, that's sort of the target that these guys have. How do I do this in 10 weeks? Because I want to monetize it, right? Something happens, like, Tesla did, for example. I think it was, I forget what was that, something happened in Florida. There was a lot of evacuation, I think some sort of hurricane or something that came in, and they updated the software, the battery management system, and they gave an additional battery range to the Teslas to come out of that area. So instead of having 300 miles, and they go 350 miles or whatever it was. So they give you extra range with a software update within 10 weeks of time to be able to update the software, build it, design it, build it, update it, and do an OTA. So so that's the kind of target that people are having, and obviously it makes some business sense, right? If I can monetize it quick, I see an opportunity, I go in before anybody else can. That's what's happening. I mean, I don't know about the overall product, but the software side of it is getting a lot of pressure on software guys.
Yes, thank you. And just connected question. So because you are going to be defining the features based on software updates or software subscription, if you will.
Yeah.
So that assumes that your hardware is already supporting, right?
Yeah.
So in which case, if your hardware does not support, then that will become kind of a limiting factor for what you can offer with software defined. So will it limit OEMs to have their, longevity, extension of the platform?
Absolutely. No, that is a big consideration now that they're doing on all of the new products and new platforms. And that's where I was showing you, we have technologies where when you are even assuming that I'm going to have these new 5, functions I'm going to be doing for this new feature, you should be able to analyze, is my existing hardware enough? And if it's not, right, what do I need to put it on my vehicles today so that I can monetize on it 5 years, 10 years out, right? So be able to do that, sort of preliminary analysis. And it's not just, chips or SoCs, is also networks, right? How all these connected, right? So the whole architectures are changing into zonal architectures and things like that to be able to do that scalability. But obviously that scalability cannot be done after the fact. You have to do it way upfront in the concept phase. That's the concept exploration phase that I was talking about. That's where you have to really, really do it. Make sure that you are putting in enough bandwidth on your vehicle so that you can do the software scalability aspect of be able to monetize on your products with software. So that's happening now, and these technologies that we are talking about enable you to do that today.
Thank you. Thank you, Piyush.
Very interesting, Piyush. I think you really touched on issues having to do with the timing and how fast the manufacturers can and have to change in terms of either providing the updates that they need. Now, did you talk about, and I think he was mentioning this, the kind of like time to market. So you've got this whole process now where you're looking at all these different things across many different time frames, seeing I want this to last a certain period of time. But in terms of the probably, I guess you would call it the design freeze, right? When you've gotten to a point where you're, okay, we're not going to make any more changes in the design, but there's these software changes that may occur before, after the freeze. Is that a challenge for the manufacturers and the suppliers, or is this now built into the process?
So I would say it this way, that there is, see, back in the day, we had that process where, you do vehicle development and you're done, and you do, okay to ship kind of thing. And that's when we sell the vehicle to the customer, and, our money is in our bank, right? Now, the paradigm is totally shifted, right? It's basically, can I have a vehicle out there that I sell to my customer and perpetually keep on making changes to it? So there's never a design freeze. It's basically just a release point where you release it and you just immediately start working on the next release of it, right? Immediately start working on the next release of it. So it's always going on. There's no freeze, no more, right? It's always a moving target, even after the customer buys the vehicle, right? So that's what software enables. And that's what these guys are trying to monetize. Like at a BMW, I think, like Satish was talking about, BMW recently announced that if you want to have heated seats, we can give you at a subscription. Well, guess what? How you do that, right? First, you got to have the hardware in there for your heated seats. Two, you need to have it enabled with software to be switched on and off, and be able to control that over subscription with the service through the cloud, right? So be able to have that kind of scalability, and that was done after these vehicles were sold. Right. So that change is always there now. It's not when it used to be when you sell the vehicle, that's what you get. You bought a $40,000 vehicle and it came with 39 features and that's all you got. Not no more, right? So I think that's a change paradigm, and I think Tesla is to blame, probably that they started this, and everybody now wants to follow that, right? Everybody sees the chiching, the money, right? That, all right, I can make a lot of money after I sell the vehicle.
Right. And that is a major change in the industry. And we're going to have to cut it off right now, but thank you, Piyush.
Thank you.
All right. I'm going to talk a little bit now about one of the companies that we've been following, who have been working on this topic, or who have been implementing this topic, Tesla. So in some ways, people talk about Tesla as the poster child for this kind of change. And so what we did was, in terms of our one of our research projects, what we call it the Tesla effect. This was something that we did back in last year in 2021. And we based this on our powertrain experts and automotive manufacturers, suppliers, government, NGOs, academia, consulting. They're giving us their predictions for 2025 and 2030, and the surveys were completed last spring of 2021. So we had about 69 responses. They cross manufacturers, the three different groups that we usually look at, as well as different titles. The survey itself looked at a number of different areas: market share, both domestic and global, Tesla's dealership model, their service model, the over-the-air technology, their charging strategy, batteries, of course, computing technology, and their business model. And what we found, and what we're going to talk about today, is the over-the-air technology, the computing technology, and the business model as a way of fitting it into what we're talking about in terms of the software-defined vehicle. Because as Piyush was talking about, the opportunity for over-the-air updates really makes a difference in terms of the current and future streams of finance streams for manufacturers, something that they really were never able to do in the past. So let's first of all look at the over-the-air technology. So we asked them how far ahead is Tesla, and they said they expect it will take 1 to 4 years for other manufacturers to catch up to Tesla in terms of over-the-air software updates. Well, we asked them about free over-the-air updates. How important are those to strengthening customer loyalty? As you can see, it's a pretty important piece of the story, and Tesla is really leading the way for manufacturers to see the effects of this. One could argue probably that OnStar probably had some of this as well. They were doing it in a different way. They were probably not pushing over-the-air updates to the vehicle, but they were providing services to people in the vehicle. Some of it free, none of it free at the beginning, all of it free, but then later on, none of it free, but still relatively inexpensively. And I remember one of the things that made that particular technology successful was that if you ever got in an accident, it would automatically call 911 and send help to you. So this is something that I think that GM was able to capitalize on. But there are also upgrades that are important to profitability. And you can see here that they expect the paid upgrades. And I think Piyush was talking about that. You'd have a Tesla vehicle that would get more battery range just by through an over-the-air update or an upgrade of your vehicle. And there's also the I think it's the $10,000 or $15,000 upgrade to go to full self-driving mode within Tesla. So there's money to be made here, and Tesla is really testing the waters for all the other manufacturers. So when we talked to them about their comments on what they thought about this topic, and they were basically saying that they are important to Tesla's success. They add significant value. It potentially slows depreciation of the vehicle and also make service quicker and easier. But it depends on functionality. While the OTAs improve vehicles' performance, some of them are just gimmicky additions that don't add much value. Hardware issues they also think that will outweigh the benefits in some ways. They cannot fully make up for shortcomings in build quality. So this was kind of their feelings about OTAs. Some of their comments were that in the longer term, particularly if and when legacy OEMs adopt OTAs, the apparent value of OTA updates feature will become less like an expectation, kind of like seat belts or Windows updates. Upgrades that significantly improve the customer experience will be the only ones that will garner customer attention. If significant enough, they could be a profit center. And also, what type of functions will be offered by OTA? Here, Tesla is still in the lead, and it might take 3 to 4 years for the large OEMs to catch up in terms of the OTA portfolio. In terms of computing technology, onboard computing technology, the experts also believe Tesla currently has an advantage in onboard computing compared to other, especially compared to other EVs. They also think it'll take, as they did for OTAs, it'd take about 1 to 4 years to catch up in terms of computing technology. As in terms of the fully autonomous vehicle, we asked them when they thought Tesla would actually have a fully autonomous vehicle, and they're estimating by 2031 for that to actually occur. And they also believe that autonomous vehicles by other manufacturers will be available primarily within that 2031, 2040 timeframe. And this pretty much goes along with the work that we've been seeing in terms of the challenges to be fully autonomous. So in terms of this particular topic, the experts' comments explained how the level of discussion of timelines for autonomous are complicated given the different levels of autonomy. Overall, most agreed that the fully autonomous driving at L5 is a long ways away, that there are serious complications, especially dealing with different road conditions and temperatures and weather. They also believe Tesla does have an advantage in autonomous driving that their competitors can learn from, though the issues that they're going to be facing and from the government, maybe things that they're going to have to look at in the future. Some of the quotes had to deal with when fully automated driving will actually occur, probably decades long, very long time from now. Very complex question that has nothing to do with Tesla, says one expert. Remember that NHTSA is still the regulatory agency, and working with them as the respondent does. He says, I don't see a clear window for L4 and L5 automated vehicles being available to consumers, Tesla or otherwise. Now, experts discount the value of on-road data being continuously collected by Tesla vehicles and making that vast amount of driving and real world conditions available to machine learning and AI algorithms. When Tesla can pair 5G technology with Planeteer and data analytics, fully autonomous driving is a few software development cycles away, not decades. So this is one person out of the experts that we surveyed that has a more optimistic view about what could happen in terms of AI with some of the advanced technologies. And finally, let's look at Tesla's business model. When you look at what they think, what has made Tesla successful, and that they tend to be non-vehicle performance related aspects. So public perception, reputation for innovation, brand loyalty, over-the-air updates, the computing power, and their batteries. Though batteries is probably one of the few performance related, but these others, some of these are, especially the brand loyalty, reputation for innovation and public perception, really gives you a view of Tesla that probably jives with what a lot of people see, and I think it was a very insightful from the respondents, the experts' perspective. But when it really comes down to it, they think the OEMs, the other OEMs, the traditional OEMs, will overtake Tesla once they commit to an EV strategy. So that was what they were expecting. They say that express belief that Tesla's competition in the EV market is increasing, and Tesla will need to improve their vehicle quality and possibly shift their focus solely to batteries to survive. Their EV market share will inevitably decrease. They also say that in order to survive, Tesla needs to make more affordable vehicles to keep up with their incoming competition. And they also believe that Tesla has played a large role in accelerating the general public's acceptance of electric vehicles, disrupting the automotive industry and pressing legacy manufacturers into speeding up the development, their own development of their own EVs. And it really fits in what Piyush was just talking about, where the software changes that are being are required of vehicles are really going to speed up the whole process of vehicle development, but also the opportunities that come once a vehicle has been sold. So some of the quotes had to do, talk about Tesla in general. Tesla has changed the marketplace and forced legacy manufacturers to change their strategy to compete in the marketplace that Tesla has created. Their supercharger network is the best in the industry, and for high mileage users, it's probably the only network that can be reliably utilized. And another expert says that they need to maintain sales, but without a steady stream of new models, the only way to do this is to drop prices. Their emphasis on range and performance will make it harder to address the emerging market for less expensive cars targeted at the wider purchasing public. They'll need to create an open used car market to support higher sales. Otherwise, outside financing will be a challenge. A lot will hinge on whether they can raise additional capital while the stock price is high. And if they do, they can survive for a long time. And also, I think at some point, the traditional OEMs manufacturing capacity and sales and service points will help them. Tesla may release a low-cost model, and they have low-cost charging, but they have not yet invented a low-cost service model to satisfy the broad market. Now, one of the reasons they've been able to survive, I think, has to do with a service model where the vehicles don't break down as often. So you don't have to have as much service done to them. But especially as vehicles get older, it becomes a much more of a challenge. And finally, for me, the biggest Tesla effect is that they proved a BEV OEM can survive and are showing the way to dozens of other startups, not just the traditional manufacturers. So that's what we have. I had to share about the Tesla survey. Questions from the audience about this particular survey? Or anybody, Kara, anybody online have any questions about this?
Features are useless, I agree. Some are very helpful, it really depends. I would say it's about a 50-50 split. It takes about 20 minutes, you can do it at any place once you have internet connection. The car is very reliable. I would also agree on the manufacturing quality a little bit, not at par with the Daimler or a BMW, but it's not bad either. It's a very good quality, it's a very different car to drive. And I have seen many co-workers that tested it, they really like it, or maybe it's you like it or you don't, particularly when you look at recuperation. And I think the Tesla, I drive a Model 3, is very reliable. I have a 260-mile range that covers 90% of what I'm doing. And the Tesla charging stations are working quite fine. I can go everywhere, I just need to do a little bit more planning. There is not a charging station at every corner, but you can get everywhere. So I'm very satisfied, and I would say I'm a loyal Tesla customer, so I would agree to that 8-point-something rating.
Thank you very much. Yeah, we know that one of the issues with Tesla has to do with the cost. I mean, these are luxury items. This is a luxury vehicle, and we expect the vehicle to act like a luxury vehicle. And it sounds like in general it does. The question will be, what will the lower cost models be like? Will they have the same kind of range? Will they have the same kind of capabilities that the luxury models? And this is true for all manufacturers. The challenge for all the manufacturers, and I think that has a lot to do with the software-defined vehicle, because we're actually transitioning to a different kind of vehicle, isn't it? It's a vehicle that obviously, as Piyush was talking about, kind of takes you to the next level from beyond getting you from point A to point B. It gets you to, it creates, provide services for you in ways that maybe you were not aware that we're actually capable of getting inside your vehicle. Now, there always are going to be drivers who still say they still want to say, I'm a point A to point B type of driver. So, and I think this is a part of the market that is not being served at the moment with EVs. I think that this is an area for opportunities. But when we think about the history of the industry, probably over the last 20 years or so, maybe even the last 30 years, you see the traditional manufacturers, especially in the US, kind of moving away from smaller vehicles, moving away from less expensive vehicles to more higher priced vehicles. And there used to be a point where small cars and even pickup trucks could be purchased at a relatively small price. And those vehicles still exist. But for many of the traditional manufacturers, they kind of gone away from that. Europeans, it's a different story, right? In Europe, the vehicles are smaller to start with, but even Europe now, probably the largest segment in Europe is the compact SUV. So it's something that is global, but it's still smaller compared to the larger vehicles. But I think that with that, other questions. We always like, Kara, do you have one?
Do you think companies like Ford, General Motors, Tesla will open up their hardware to developers to create services akin to apps in the Apple Store?
Very good. Yeah, that's very good question. When we talked to the experts about this, and this is actually we're getting a little ahead of ourselves. Our next speaker is going to be talking about some of the challenges and the opportunities that manufacturers face. And one of the questions that we have for him has with the introduction of Apple CarPlay and Android Auto, and the kind of the goal of Apple in particular to take over a larger share of the instrument panel. Will they be able to tap into the data that the users are using and that they are providing, and be able to provide their own services to the drivers? And will that or will the manufacturers say, no, this is really an area where we want to, this is going to be one of our profit centers. And I think that this is a challenge that the manufacturers are dealing with probably as we speak, in terms of the how they're going to be able to approach this. We know from experience that they don't want them to do it at all. You know, if it wasn't, if consumers were not requiring that they have Apple CarPlay and Android Auto on their vehicles, they wouldn't have them on the vehicles. But it was because consumers just made such a hue and cry about being able to connect to their vehicles with their phones that it just made it impossible for even the Japanese, who are very reluctant to have other technologies on their vehicles, to actually have that offered on their vehicles. And the question becomes, well, why was that? Why did they feel that they were forced to do this? Is because they themselves had not created the technology and the interface within the vehicles so that they can actually connect their phones in such a way that they liked the phones, the way the phones did things better than what the applications on the vehicle did. And I think that was one of the big issues. Priyush, did you have anything you want to add on this?
Yeah, I mean, that was an interesting question. Actually, I had two things. One, to sort of add to the answer you gave about this whole apps kind of thing, and then on the Tesla side of it. Yeah, for the sort of open aspect of apps, I think the Ford and others have already been doing that, but not at a sort of an open scale, if you will. There are SDKs that you can actually access, Ford Sync, for example. But now, since they're moving on towards more like whole, Google Cloud and Android-based, and especially for infotainment, I think that opens up a lot of opportunities. But at the same time, they want to really consider cybersecurity, right, aspect of it, and how do you put controls over certifications of apps that are coming in on their platform. So they are thinking about these mobility platforms where Ford would provide, or the OEMs would provide these sort of mobility platforms on their vehicle systems, and be able to, for businesses, be able to use that platform to put apps on it and be able to leverage vehicle services to build new business models for pizza delivery, for example, or whatever be the case that you want to do with that vehicle. Or even for businesses where they have, you can put like RFID tags on tools and things like that on an F-150. So you can have, the truck can access information about what tools are available on the truck, so that when you go for a service to a job, you know what tools you have, and a central monitoring system can actually access as to which truck can be routed to which service, things like that. So that opens up a lot of opportunities for these OEMs and third-party apps to kind of monetize on. So that's already happening, and I think these platforms, as they come in, it will become more on a hyperdrive almost, if you will. So that's one side of it. The other one, I wanted to comment on the Tesla that you mentioned. Another thing that I didn't mention much about Tesla is I was recently reading an article where they have, since 2017, Tesla has reduced their cost to manufacture, cost to build the vehicles by 57%. 57%. So it used to be about $80,000 is what would cost to build a vehicle. Now it is about like $36,000 to build a vehicle. So the reason I'm kind of mentioning that is I feel that there is a almost like a revolution happening on the manufacturing side of it. They started to call it third revolution of manufacturing, I guess, because how do you simplify the manufacturing process? Because now there are less parts to build from. The number of parts on the vehicle on an EV are much less, right? than an ICE vehicle. So how do you simplify manufacturing processes and be able to cut costs on building EVs? So that's another thing. And obviously all this software thing kind of helping, because now you have less and less, instead of having 80 ECUs on a vehicle, you have 5 or 3. And now everything is shifted to the software side of it for complexity. But from a building standpoint, from a manufacturing standpoint, it's much easier, much simpler. Is everybody leveraging that? Probably not yet, but everybody's looking at that simplification of manufacturing processes to get the cost of the vehicles produced to lower. So that's another interesting.
Now, Piyush, when you look at the manufacturers that you guys work with, are they separating their development of EVs from their ICE development and treating that development differently in those two different groups?
No, I mean, I don't say differently, but they're going more towards what they call flexible manufacturing. So on the same line, I should be able to build, this or that vehicle kind of thing. So they're doing that kind of thing because they are, the big manufacturers like Ford and VW and BMWs and they have this whole range of the ICE vehicles as well as the new EVs, right? Ford kind of split that, from a business standpoint, Ford E and but from manufacturing standpoint, they still have. They want to leverage all the capacity that they have, right? It's all about the capacity piece where how do I leverage what I have and build EV as well as a ICE vehicle on it. So that's from that perspective is more of a manufacturing flexibility problem to solve. But from a new startups and new OEMs that they're popping up everywhere, they are all focused on this, cost aspect. How do I simplify manufacturing? Because manufacturing is not their expertise, if you will, right? All this engineering aspect, they can bring in new blood and new, young crowd to kind of build and design vehicles. But as it comes to manufacturing, you need 100-year experience to kind of, simplify things for you. So they are more focused on the simplification aspect of it. The startups are. But the bigger ones are more focused on the flexibility aspect of it. How do I manufacture flawlessly while having a flexibility for what I want to build?
Very good. Any other questions? Carrie, you have another one?
From our audience, Tesla has contributed to the development of EVs, but also pushed OEMs to install large capacity batteries. Can they really change their model and reduce the carbon dioxide impact of EVs with smaller batteries?
Okay. All right, smaller batteries. I think one of the issues we've read about is that obviously the production of EVs is not CO2 free. The production of these vehicles and the batteries that go along with them is not CO2 free. So I think some of the early analyses of this kind of said that actually there's more CO2 emissions from the production of EVs than there is from a typical ICE vehicle. But the CO2 reductions really occur once the vehicle's on the road. And again, where's that electricity come from? That becomes the other issue, right? So EVs are not one could argue they're not the panacea for CO2 emissions completely. They are a step in the right direction, especially if you can get cleaner power generation. And now, but you still have the CO2 emissions that comes from mining and the transportation of the minerals and the digging for minerals and the processing of minerals that go into the batteries, and also everything else that goes into the building a vehicle. So there's, as I said, it's not CO2 emissions free. And I think most people understand that, but and I think in the industry understand this, But I don't know, I'm not sure if the general public understands this as well. Any other questions? Okay. Let's take our break at this time. We'll do, I think we're gonna come back we're gonna do 20 minutes. And let's come back at about 11:05, and we'll start with Howard Abbey from SVD Automotive, talking about some of the challenges as well as the opportunities that manufacturers are seeing. All right, thank you. All right, our next speaker, Howard Abbey from SVD Automotive. Howard has managed and supported projects focused on off-board hybrid compute architectures, open source selection and hardening for automotive, cybersecurity analysis, and sensor spoofing. Howard has over 15 years automotive electronics experience, much involving facilitating incorporation of smaller technology and data providers. Prior to joining SVD, Howard worked in R&D at Aishin, prototyping location and situation responsiveness systems. His expertise includes advanced in-vehicle computing trends, embedded systems, map data collection and compilation, sensor technologies, software-defined vehicle trends and technologies, and ADAS and autonomy. Welcome, Howard.
Thank you, Bruce. Let's see if I'm somewhat in camera view. Somewhat. All right. Thanks everyone for coming face to face. It is greatly appreciated, as said earlier, and to those online streaming now and watching later. It's great to talk to you. Yep, talk a little bit closer to the mic, and that way I can be heard. Good. All right. I'll be focused on software-defined vehicle and some of the aspects building up to it that OEMs and tier ones need to provide in order to make it a success in the industry. So, see if I can change slides using a different button. There we go. First off, SB Automotive, the company I work for, is a market research firm. We provide off-the-shelf reports and planning data sets to OEMs, to tier ones. We count the majority of OEMs. It's actually 65% of tier ones and 95% of OEMs as our clients on a global basis. Most of the analysts have come from the industry, as I have. As mentioned, I've got a long experience with maps, navigation, ADAS, and autonomy. We have a global reach. We have offices in the UK, Japan, China, India, and US. Ann Arbor is the office I'm based out of, about 20 minutes west of here. So very glad to be in a close location. Also want to mention that we do cover the full cases, so connected, autonomous, shared, electric, and secure. And the autonomous is one aspect that really utilizes a lot of the compute, a lot of the software definition, as well as the connected infotainment side. So both of those really have prepared my organization to learn how these things are getting implemented in the real world. Just a quick overview of the various things we'll be talking about: electrical architecture platforms, the vehicle itself and the ecosystem around that, and the transformation of organizations that'll be needed to support that in an efficient way. And then how do you get users to buy it or to want? So, software-defined vehicles. What is it and why do OEMs care about it? One of the key things of software-defined vehicles is that it separates the hardware design cycles from the software design cycles. But why are OEMs going forward with this? Is this just a marketing fad or is it something real? We fully feel that it is a real environment that needs to be accepted by the whole industry and is being accepted by the large tier ones and the OEMs. The reason they're spending this money to invest, and it's a lot of money needed, is because they see these advantages. This is confusing. Online, I need to point this way. Here, I need to point this way. But these advantages of software-defined vehicles will take over the industry and give competitive advantages to the companies that do it first. and long-term advantages to those that keep with these advances. A lot of talk about Tesla being a leader in software-defined vehicles, and a lot of their reason they have speed to market. They have the opportunity for after-sales revenues. Some of these things is because they have designed from the ground up to be software-defined, to have that flexibility. It's also been mentioned their bill of materials can be less, or in the case of their front radar, they can remove things from their bill of materials and make up for that hardware lack by changing the software. So some of these things is really an advantage to Tesla and the other companies that are advancing with software-defined vehicles. Also want to mention that it has challenges. Tesla's quality is one of those challenges that they focus so much on the software that some of the money investment on the hardware they should have spent, some of the gears, some of the physical things isn't there because they've had to balance where their focus was. Also, the challenge is getting this right as an industry with the cooperation without having to remake the same software over and over and over again. So architecting your platforms to allow this is important. The last item on the list here, vulnerabilities, is one of the it's Siemens earlier mentioned the cybersecurity aspect is so important. And it's one that the OEMs now are fully engaged with and the tier ones are fully engaged with. They recognize it, but it is something that is a cost that needs to be paid. And it's not a cost associated with a feature. Like you used to be able to say, oh, I'm having an extra camera. I have to do XYZ for that camera and bundle it as part of the piece price, part of the vehicle price. These vulnerabilities and the systems to avoid vulnerabilities, systems to remediate vulnerabilities need to be at an OEM-wide level. And making sure that's budgeted is one of the challenges that software-defined vehicles will help address by reducing that cost, by making vulnerabilities easier to deal with. But it is a result of the way the industry is going. All right. Again, things I'll be talking about really build upon each other. The vehicle platform is significant in that it's the basis of all the software. You can't have software without something to run it. These are the four aspects that I'll be covering. There's other aspects that are equally important. I just talked about cybersecurity being one of it. Another is the user experience. Very important to have customers actually like what they're driving, not to hate the fact that the car doesn't have a turn signal stop. It'll drive users away, perhaps. So those I don't decide to leave out due to time and due to other speakers, but I wanted to make clear that these are things we see important for the industry. All right. Next, I want to go into some of the advancements of electric architecture platforms and how we see the different OEMs going forward. It was mentioned that the next generation vehicles or so will have some of these software-defined vehicle advancements. Our view is very similar. We see 4 levels of advancement in changing the way software and features are delivered in cars. We have the functional architecture, the basis. This is the old traditional, you want to add cruise control? You add a cruise control module. You want to add cruise control with radar? You add a radar specifically to cruise control connected to that cruise control module. Every feature gets its own module. That is not feasible or not cost efficient when you have hundreds of modules in the vehicle, all wanting access to the GPS, all wanting access to the speed pulse. You want to make your network centralized so that the same signal can go efficiently to every part that needs it. And that's the next generation. You arrange your networks, you connect these modules, you start merging some modules together so that the systems are more efficient. However, it's still many modules, much focused on features with the bandwidth the network provided and providing for future upgrades that was mentioned earlier by Siemens. The next level is domain architecture. And this is the one that we see coming out quickly for some of the leaders and coming later for others in the next generation. This is where you'll have a central domain controller module for cockpit. You'll have a central domain controller module for ADAS. You have a large compute processor pulling in remote sensors, pulling in remote interfaces to the user to be able to implement features as more of a grouping, and those individual features will be added to that grouping. Oh, you want cruise control? Just flip the software into this system. Oh, you want the advanced cruise control? Just update the software. So this is where the hardware starts to be disconnected from the features that you're offering. And then the goal that we're talking about, the future that's always been a few years away, is software-defined architecture. I claim that some OEMs have it very soon, but nobody has it today to the full extent of where the hardware is completely decoupled from the software. And that level of decoupling, there are always going to be some level of attachment. And it's going to be an improvement, but never a completely independent system, except when you bring in the cloud connection. So that's where I think the software-defined architecture with the cloud connection will be off the chart. It's not on here yet. It'll be in the 2030s timeframe, but you're starting to see hints, starting to see early implementations of that even today. Other things I wanted to make sure to mention was the exact placement and timing of various OEMs here. You can debate the interpretation of what one OEM calls domain versus another. There's arguments of that, and you could get into the details, but the focus of this is to show the trend, to show that most OEMs are progressing and the industry is progressing to more and more software defined. It's been mentioned earlier, Tesla is a leader bringing EVs and leading software-defined vehicles. And part of that is because there's a natural affinity. EVs allow major refreshes of architectures. If you're building a new one from scratch, or if you're a Ford having the Ford E projects, by definition, if you're doing an electric vehicle, most of the electronics in the car will be replaced, will be doing something different. So being able to have the electric vehicle transition is a key enabler to get OEMs to make the transition to software-defined vehicles. One of the aspects that I mentioned is the electronics of the batteries. The other aspect I want to mention is maintenance. It's been said earlier, Teslas have almost no maintenance. I'll show you later the maintenance that Teslas have. The software needs to be updated. That allows the system to have updates for cybersecurity, for the software, for the battery range management, without having to go into a dealer. That type of maintenance platform that has to be put into place to support the batteries is enabling support for ADAS, is enabling support for other features. And all of that infrastructure can be used by the internal combustion engine system as well, once they get it in place. And even OEMs that aren't providing EVs as their main focus or as a large focus, they are being pressured to compete with the EVs. So they have to do the same style of over-the-air updates or of doing recalls without making a user come into the dealership. So the EVs are the reason, but not necessarily the only affected party for this. EV business models is another thing that's really changing the industry. Not tightly tied to EVs always. The Tesla direct-to-consumer model, Rivian, others have really changed the relationship with the customer, bringing it more customer and the OEM having a direct relationship. But you've also got VinFast and others who are doing battery swapping. And that, again, brings people to the expectation that my phone will have a stronger connection to the car, will provide me information about the charge status, about the ability to preheat. So those types of things also lead into the ecosystem. The ecosystem is needed to find the next charger, but that charge cable gives you a reliable data connection to the car. Plug and charge is the reason it's implemented, to be able to pay for it without the user having to dig out their phone and dig out credit card and figure out this new tolling system. Make it easy, make it simple. But once you have that data pipe, you can use it for map updates. You can use it for the software updates that these vehicles need. Moving on to the ecosystem. As I hinted to earlier, Tesla is ahead of most, but they've got neck and neck competition. The XPeng, the EV disruptors are close to having many, if not all, of the features of software-defined vehicles so that they can decouple the hardware from the software. But VW, BMW, others are close behind. VW took a big risk with the ID platform. They paid for that because it took them a long time to get that to market. But now they have it on market and they're starting to be able to keep the car fresh with updates. Ford is well on the way as well. They've got a lot of the infrastructure in place on the Mach-E, on their electric vehicles. And they're starting to roll out some of these to their combustion engine platforms as well, but it's a step behind. Whereas people like Stellantis, Nissan, they're more focused on digitizing the infotainment system and keeping it up to date, keeping it fresh, keeping that and their telematics up to date. Whereas other OEMs, some of them are still stuck in the, there's a new feature, let's add a box, or how can we adopt what the other OEMs have made and integrate it into our system. So there's a wide range of where people are, and even within an OEM, different platforms will be on different stages. So the functional platform is not going away. And with the increase of software capabilities for CPUs, with the increase of bandwidth in these vehicles, the functional platform may be the right answer for certain markets, for low cost, for very reliable. I'll use the example of the Ford trucks. Yes, there's the Ford Lightning. It has all the latest and greatest electronics in it. But there's also the Ford trucks that don't necessarily have powered windows because that vehicle is going to be ripped apart and be turned into a camper van or a workhorse. So that range will continue to exist. But the capabilities of software-defined vehicles, of over-the-air updates, will even influence how those are designed. Next, I mentioned the fact that there's a lot of architectural shift needed. This slide is an eye chart, but it shows the layers of abstraction. The key point of software-defined vehicles is that you're no longer tying everything so closely to the hardware. How can you efficiently do that? By layers of interfaces, by layers of APIs that can stay static while you change the hardware. As long as that interface stays the same and is tested to be robust, you don't have to retest all your software. You don't have to retest all your applications. Similarly, if you have a steady traffic feed into the car, RDS-TMC over IP, that traffic feed can update, change suppliers. You don't have to change your software. You don't have to change any of the hardware. That decoupling is what we mean by software-defined vehicle. It might even be better phrased software interface defined vehicle. The definition of the software is what defines the vehicle. Another thing that really we see coming into play is the multiple mixing of operating systems in vehicles. Real-time OSs, along with things like general purpose OSs like the QNX and Linuxes of the world, playing side by side either on the same system or on modules beside each other. But the focus is the OEMs wanting to reuse that system across vehicles, across platforms. And I can go through every stack and say the same thing. The reuse is getting to be a realistic thing now, whereas previous legacy products, it was a goal. It was something that was always stated. Oh yes, we need 25% headroom in our networks for future needs. But by the time it launched, it was pretty well set. It was pretty well not touched because of the worries of validation and cost. So what OEMs are spending the most on software? Through one of our market analysis, we've looked at the top software spenders by OEMs. VW, I mentioned the ID platform. They are leading by quite a bit of their software spend. But unlike Tesla, which is way down on 11 in this chart, VW is doing a mix of insourced and outsourced. They have their own engineers, but they have their traditional tier suppliers. They have new suppliers of just software that they are bringing to the mix. And Toyota is taking it even more so that they rely on their KRETs, no surprise, but they continue to utilize their suppliers in a strong collaborative way to develop the next generation vehicle. Let's see if I can get rid of this top for the people online. Not easily. Okay, sorry. But on the other hand, the availability of developers for these companies is a challenge. One of the reasons why Toyota and VW have to insource what they outsource so much is because they don't have the developer tool that Tesla does. Tesla has a draw for software engineers. A software person looks at Tesla and says, oh, that's a cool company. I want to work there. So the number one challenge to getting more in-source, in-house development is recruitment. And you see this in some of the events being put on by OEMs. Ford, VW, Toyota, mainly Ford, VW, and Tesla, I'll say. I've seen clear events that they are no longer promoting their cars to the end users. They're no longer promoting it to the dealers. They're having a tech day to show that their tech is cool and you want to come work for them to develop the next generation of AI or the next generation of whatever. So the recruitment is appropriately a big investment now of OEMs. If you're like Tesla, it is where your marketing budget goes now. They don't have a marketing department, but they sure do spend a lot on trying to recruit people. Another aspect, another challenge, as has been mentioned earlier, is the ability to scale. The old way of doing the V model of having every single part in a complete system and testing it together and verifying each model through the whole testing process of months and months and months is an expense that is not competitive anymore. It's still very important to test for safety. It's still very important to have new tests in for cybersecurity. The homologation of the UN ECE in Europe of Regulation 155 and 156 do not let OEMs off the hook for the needed documentation that they've done the right thing. But the ability to reuse documentation, to be able to reuse modules and tests across vehicles is something that this decoupling that software-defined vehicles can offer. Next chart's a bit of an eye chart, so apologies to people in back, but the flow is the main focus here. Efficient software development is needed by OEMs as they migrate their existing legacy structures into this new style. They need to keep the safety elements from the past, but they also have the challenge of harnessing their strong supplier base across their whole platform, sharing, as was mentioned by Siemens, the requirements on an agile, up-to-date basis to all their suppliers, to all their software engineers in-house and outside. They also have to make sure the software supply chain is secure and well understood and will work with both the current generation of hardware and the next generation. One of the ways they're doing that is moving away from device drivers on the hardware level to a hardware abstraction layer so that the software runs in a runtime or in a container. And that way it can be tested on the cloud or on test units without the actual vehicle. And then when the vehicle is available, they can load it and have confidence that it's going to work correctly. Another aspect that's important is to be able to have a point where these runtimes are portable between compute locations, not just between vehicles, but even on one vehicle. You may get to the point where your ADAS compute is not quite powerful enough to run this new feature, but you've got extra horsepower on your infotainment while you're driving down the road because everything's locked out for security. So having the ability to move a runtime container to your infotainment and be binary compatible gives the OEMs that flexibility to go over and above what they may have planned at initial launch. It's often said that software fixes many recalls because of a software bug. that many times the actual bug was in the hardware and the software is a workaround, a very effective workaround, but a workaround. Now, the next step will be when those workarounds happen in the cloud so that the software on board the vehicle doesn't even have to change, but the linkages are there. The latencies are low enough that you can run some of these features in a container on the cell tower next to the vehicle and have it follow the vehicle and even get inputs from multiple vehicles, multiple sensors from multiple vehicles to provide new and interesting features. Or if the vehicle is going out of range, to be able to pull that same load dynamically into the vehicle so it can continue the processes. It was mentioned earlier, the fact that OEMs have somewhat resisted and somewhat embraced apps coming into the vehicle. It's clear that OEMs tried. Smart Device Link by Ford was a clear one to get app developers interested in developing for the head units, for the in-car experience. The volumes of the few OEMs that participated wasn't enough, as opposed to the Apple and the Google app stores, which are well known, mainly because developers could just tweak what was already there, what was already being made for a in-car experience when the users put their phone on the mount. So those collaborations with the tech giants will continue, and Apple in particular has recently announced their desire to get into the dashboard cluster. But the OEMs need to be careful about what they will give and what they won't, what level of sensor data, what level of access to that cluster. Because repeatedly we see in our user studies, when something goes wrong, it's the OEM that the customers know and trust to fix the issue. And they know liability rests on the OEM for safety. In China, it's also very interesting. You see Baidu and Huawei really getting more involved in infotainment, not just in the projection systems, but actually providing infotainment hardware and providing cloud services. So they are really getting involved. On the other side, the open source part of automotive has gotten much bigger than it was in the past. It is something that Genevieve Covessa laid the groundwork for, but now you've got Sophie looking to implement some of the container features that I mentioned earlier. We also have the crossover of that with IBM and Red Hat working with GM to make their Ultifi platform. And it's going to be really interesting to see if Red Hat gets the community involved as they're trying to for the Red Hat in-vehicle OS. They want everyone here to be involved so that not just GM's view, but the whole industry view can be brought in. But again, we need to sell this. And to sell it to the consumers, we need a few things. One is these software-defined vehicles provide OTA. And that OTA is important to deliver in an effective, efficient manner that gives revenue to OEMs or at least cost savings. As a result, which domains do you want to focus on for the over-the-air updates? Infotainment and connectivity are no-brainers, but when do you bring in the ADAS? When do you bring in powertrain? Those types of things need to be thought of. Also, what type of content? Will you just use it to avoid recalls and fix bugs? Or will you give people better performance as you can develop it? Will you extend existing services or brand new ones? Will you just offer a new gaming thing, or will you actually give someone something they value every day in their car? And will you charge for it? BMW, with their attempt in some markets to charge for heated seats, showed that this is a very touchy subject, depending on region, depending on market segment. Similarly, what update channel? Wi-Fi, having the user connect to their home Wi-Fi has been one that's we've seen a lot, but also being able to do so with the embedded cell module is something we see easier for OEMs. And we've done a few studies on the user experience of software updates. And right now, there are some good ones, there's some very good ones, but there are also some very bad ones. And even when you consider cell phones where users have a known good experience, even there, the rate of updates is quite small. So for cybersecurity things, the choice may need to be made to prevent liability issues to force updates on users. So you need to be very careful how you do that and how often you do that. So frequency of the updates is another key thing to be efficient. And that's one area where we kind of talked a little bit earlier about Tesla we see Tesla really improving over the years on how frequently they put out updates. 2019, they had less than 75, I think it was. 2020, well over 100. Now, 2022, even so far in the year, they are over 100 updates, and we fully expect them to be over 200 by the end of the year. And it's across all aspects of their vehicle. Gaming is the largest number of updates, yes, but so are other systems. Safety ADAS, full self-driving, that makes sense being second. But batteries, convenience features, there's a wide range. And they aren't the only ones. GM, Mercedes, BMW, Ford, all have or have the architecture to release updates on a regular basis. Another aspect is, as I mentioned, features as a service, setting the expectation that the user will have ability to buy things after sales, aftermarket from the OEM. I've listed there the OEMs that support it today. And as you see, a large part of them are the Chinese EV startups. But VW, through their EV ID platform, is a key leader in it as well. I mentioned earlier that connectivity is where most of the updates are happening and being willing to be paid for. Users understand that they have to pay for the network connectivity. So paying for a connectivity feature comes less as a surprise to them. ADAS leads because safety is very important. EV platforms leads because it is something that is new and users are more used to new features. Lighting, comfort, and infotainment, that is less, and we see that staying less for a long time. 57% of consumers are very interested in features as a service. That question was asked with the assumption that the vehicle price will be less. If they feel like they're paying full price for the vehicle and then being charged again, that's why one of the top barriers is customer acceptance. OEMs need to be very careful about what they try to push on customers. But those revenues are very attractive to OEMs. From a consumer side, new services after the purchase is one of the reasons they really like the idea. To be able to get the latest version of the ADAS is another thing that is appealing to them. But the fairness, the ability to switch things off is something that is a key concern. Rightly so. We've had cases of Tesla switching off features to users either by accident or through a bookkeeping error or through a misunderstanding of what was quote unquote sold with the vehicle. But overall, the features as a service will grow, but will plateau fairly soon for OEMs. My last slide talks about, again, how the different OEMs are proceeding on this journey. Most OEMs don't have in-market or announced features as a service, something that the customer would subscribe to. GM and Jaguar Land Rover, they have systems ready. They've made some announcements. Ford's made clear announcements with timings. But there's a large number and growing number of deployed systems out there. Again, the Germans, again, the EV disruptors. And we feel NIO, XPeng, and Tesla really are leading the game in many of the ways that software-defined vehicles can enable features as a service, can enable customer interaction, brand loyalty with new features. So again, thanks for your time. I look forward to all the questions and continuing some of the discussions we had off microphone earlier. If you want more information about our reports, please go to portal.spdautomotive.com. All right. Thank you, Howard. Yeah, we got a few questions for you. I want to start out with the something you said a little later in your talk about keeping the hardware up to date. How do you keep the hardware up to date? Is it something that you can swap out in and out of the vehicle to be able to keep it up to date? Because it sounds like this is really the base of which the software has to run off. Unfortunately, the real answer is no, you don't keep the hardware up to date. You sell a new vehicle with new hardware. There have been multiple attempts, Audi, Jaguar, others, to have swappable modules. And the effort that Tesla did of swapping out their ADAS computer was amazing, but I don't see that scalable widespread. Instead, you want to keep your hardware flexible enough and build enough capacity in ahead of time to support future features. But what you can do is you can adjust where the compute happens. As I alluded to, you may want to have overpowered infotainment, and you want overpowered both infotainment and ADAS, but you may expect to use your ADAS closer to capacity and your infotainment less so that you can swap compute location based on where your needs are, based on what your future customer demands are that you can't predict now. That is the large challenge of updating hardware, is predicting the future. You want to try as hard as you can. Every year you want to make evaluations based on what you're seeing in the field and upgrade your future hardware to match that. But the hardware is fixed. Another thing that's not fixed, though, is the cloud. Being able to tie into that flexible compute resource and adapt. You don't need much today, but you do need more in the future, is something that if you architect the system to support it, you can have that flexibility for the future.
Very good, thank you. In relation to that hardware, software story, why do you want to decouple software from hardware?
Because efficiency doesn't matter anymore. Old automotive software, old embedded software, you had to be very efficient because you had a very tight power and life cycle and cost of the hardware. But now the chips in cars are getting more, same as PCs, same as the cloud. They're getting cheap enough that you have process time to waste. So it's much more beneficial to save developer time because the resource of developers is much more tight than it is the resource of so many operations per second on a CPU. That is why the decoupling lets you save resources by reusing software across systems, lets you save resources by reusing the same platform across multiple nodes.
And I ask you these questions because this is really an expertise of yours. You know, you've done a lot of work on the hardware side as well as the software side. One of your earlier, we have a question online from one of the attendees online that says, why does SDV, software-defined vehicles, decrease the bill of materials? It says a vehicle has basic functions and regulations requirements to fulfill with mechanical parts, whatever the importance of the software.
There's two ways SDVs will and are decreasing bill of materials. One is the ability to make and let me rephrase it, decrease the cost of manufacturing the vehicle. The bill of materials is part of it. If you can have a common bill of materials across more platforms, that reduction of complexity of logistics, that reduction of complexity of maintaining your inventories, reducing down to one wiring harness instead of 20, that reduces cost. The other aspect of it is that so many of the vehicles today, so many of the features are software focused. So having a specific module for this feature and having another module with the same CPU for a different feature makes no sense. You want to save the hardware costs by providing both features with different software on common hardware.
Very good, thank you. Questions from the audience? For me, the cloud issue, the connectivity to be able to have and you talked a little bit about latency, and latency is not a big deal for some applications, but other applications, it's crucial. And to consider using ADAS with cloud doesn't sound like a good plan to me, especially when you go into a tunnel. And this is the idea of, and we've seen this in work that we've done on connected vehicles, where the vehicles need some kind of infrastructure support rather than just vehicle to vehicle. They need some kind of thing to bounce off of, so that they farther down the road they'll be able to understand what's going on. Does cloud substitute for that infrastructure? Does 5G substitute for that infrastructure? I know in the past, about 5-6 years, there's been a lot of focus on DSRC as the way of vehicles talking to each other and the infrastructure. But really, 5G is really coming on strong, but there's still a lot of implementations that still has to happen because of within 5G. How do you feel about this story?
Well, to answer one of your questions clearly, will it substitute? No. Will it change? Absolutely.
Substitute for
The cloud
Yeah.
will not substitute for onboard operation, but it will change the way the onboard operation works. I like the example that's in the market now of voice recognition. In-vehicle voice recognition used to be onboard only. Then the phones did offboard only, where everything went to the server. And it had a lot better performance. So people got used to that performance. Now in cars, you have hybrid. You have a minimum level of functionality in car. But when the connectivity is available, the vehicle asks the cloud. If it gets an answer quick enough, it uses the cloud's answer. If not, it'll use the onboard answer. And many aspects will need that type of architecture. However, with 5G, the latencies in general will be less. With the ability for some of the near edge and far edge systems, you will be able to run compute applications closer to the vehicle, so those latencies will be less. DSRC has been pretty much replaced by the cellular vehicle to communications platform, and that gives fairly good latency for certain applications. But it will be important for cars to recognize that the onboard sensors, the onboard information is more available and available right away. The other, I'll call it innovation, although it's obvious in hindsight we have now, is connectivity maps. Your vehicle can know where it'll have connectivity, where it won't, because it has a map of where the cell tower coverage is good. So if it's going to be headed into a dead zone, it can preload, it can cache all the needed data and even software onto its onboard systems to handle that dead zone.
Very good, thank you. Last question before we move on. The dealerships. How do you see them playing out in this software-defined vehicle world?
Now you're going to an area that's more foggy and hard to predict. We have the examples of Ford being much more strict with dealerships. We have GM with the offers to buy out dealerships who don't want to go to EV. And I see part of that as also the buy-in to the future of more and more features being sold direct. Tesla has, for good or bad, laid the groundwork that the traditional dealer model has its challenges. I do not see Tesla or other startups ever going to the way the rest of the industry has with the dealers. So OEMs will have to find ways to come to compromise with their dealer networks to match some of the things that are offered by Tesla. But don't get me wrong, dealers still provide a very important role. I know multiple people who will not buy a vehicle, and I'm one of them, without a dealer close enough that I'm comfortable taking my car to in case there's an issue. I don't trust that Tesla will be able to come to my house or that Bell Tire will always have a good relationship with Tesla based on what Musk might be doing this week. So dealers have a role to play, but it's a changing role. From a software perspective, they will be cut out from delivery of software. They have been, in large part due to right to repair. Right to repair requires whatever a dealer can do, any shop can do. And from a security perspective, that makes it very hard for OEMs to give some features to dealers because they worry about the security of the software ending up in people's uncontrolled hands.
Very good. Thank you, Howard. Oh, we have one more. Yeah, Kara, what you got?
Go ahead.
It may be for Howard and for Piyush. What about the size of the automotive software market, embedded and cloud today versus growth, let's say 2030? Do you have any estimates?
Not on me, we do.
Yeah. Unfortunately, I didn't bring that data piece with me and I don't have it memorized, but we do see significant growth. We've done work for clients on the cloud side, and they also have significant growth opportunities, both in infrastructure and software. On the onboard side, there's a lot of growth happening from new players in terms of what can be brought to the car and how best to monetize those. I'll have to get back with you on the numbers that we have in our research. Sorry, I don't have them memorized.
Very good.
Thank you.
Very good. Thank you very much, Howard. Piyush, do you have anything on that
No,
topic?
actually, I was the one who asked that question, but I had my my own sort of perceptions of how much that business is, and to my gauge based on stuff that I've seen across with Kambashi and others is about a $5 billion business today versus probably growing to almost 15 billion by 2030. But I might be wrong. I mean, I'm just trying to assess as to how big this market is and how fast it's growing. I think it's in the double digits, at least like 15 to 20% CAGR. So I was just trying to see as to what if there was an estimate from SBD on that.
Yeah, I think that, I don't know if we count the information that I was giving in my presentation of the $400 billion by 2030. I mean, it shows you that there's a lot of opportunities there for growth in the software market. I think we're going to ready to go to our next speaker, Robert Castor. Bob, are you with us?
Yep, I'm here.
Okay.
So sorry.
Oh, there you go.
It'll be
All
a
right,
little
welcome.
slow. I'm in Brazil actually today. We're ramping up our cybersecurity team here in Brazil, and I'm working through getting that working here. But let me share my screen.
Let me do a quick intro for you, Bob.
Go for it. Yes.
So Robert is the chief technical expert leading the product security team for Bosch in the Americas, which is one of the reasons that he's down in Brazil today. Throughout his career, he's received several patents on automotive safety and security and has been honored 3 times as a Bosch Innovator of the Year. Bob served as the co-chair for the Umtree MTC Cybersecurity Group from 2016 to 17, as the chair of the Auto ISAC from 2018 to 2021. He's a doctoral candidate in automotive cybersecurity at the University of Michigan. Welcome, Robert.
Okay. Well, thank you. I was glad when you asked me to participate, and I'm glad that it worked out with the calendar. And let me share this here.
Yeah.
And I've got a presentation that I wasn't sure exactly on how or who we'd be talking to, so I wanted to give a basic introduction to what we see as cybersecurity playing for a software-defined vehicle. eScript is a division of Bosch that is responsible for doing the cybersecurity for the software-defined vehicle, so I have some material from them. But what we see as say software-defined vehicle, there are some advantages to doing it just from maybe it's sort of cool. We're able to use the additional processing power in silicon and trade that off with copper wiring and such. But I think that the big driver for this is going to be the features that we can get that are enabled by a software-defined vehicle. So autonomous driving, a personalized driving experience where you go from one vehicle to another vehicle, but it still keeps track of who you are and how you like to drive. Being able to roll out content after the product has launched, and being able to add new features, having mobility as a service where you don't just have a car that you own, but you use mobility, and you can maybe have different vehicles that you could think about, or getting from point A to point B and with different things rather than taking your car from point A to point B. Having connection or connected mobility, that's also something that we see as another feature that we can enable, where we have significantly better connectivity in the ecosystem than we have today. Collecting and using big data is another big driver that we see, where we will be able to understand more about what the vehicle is doing and use that to provide a better experience for the passengers or the drivers. The ability to use artificial intelligence either in the design of our vehicles and optimizing the designs, or adding new features so that you can have or enable functions that today are not possible without artificial intelligence. Electromobility, where we start to use electric vehicles more than gasoline or combustion powered vehicles. And then shared mobility, where you can have a car and then let it go off and drive other people when you're not using it. That I think that all of these things are, say, cool new features that will probably have a stronger drive towards software defined vehicles than just the having new architectures or supporting new architectures. With these powerful new features, we also see some significant risks that maybe some of them are out there today, but not as prevalent, or new ones that these new features would enable attack vectors and risks that we don't have in our systems today. So I think the complexity and the connectivity of a software-defined vehicle ecosystem are increasing the attack surface. And it's not just that we have more connectivity, but the combination of both connectivity and complexity associated with software-defined vehicles will create new risks for cybersecurity. And then we would have new requirements for protecting them as well. There's, I think that you can look at different sources and get different numbers for how many cyber attacks that we've had in the manufacturing industry or in the automotive industry or on vehicles themselves. I think most companies aren't really comfortable with sharing detailed information about how they're attacked. I know within the Auto Isaac, we've had NDA protected discussions where we're trying to share information within the industry, where we work together as an industry as a whole rather than as an individual company. But these numbers are from published sources where we've seen in the news for several different industries and companies that have been attacked just in the last 6 months or so, that are significantly more intrusive than what we had expected even just a couple years ago. And we see security as a key enabler for a software-defined vehicle. The three main goals that we would be looking at trying to support would be to protect the safety critical systems and the safety of road users. That's clearly, but when we think of a car, safety is something that has been in our DNA for a long time, and having robust security to enable robust safety is a must. We want to also protect the privacy within the vehicle and the ecosystem, that as we have this enhanced connectivity and the collection of more and more data, that we see privacy concerns where people with that data, that people want to make sure that it's being used, or that they're being used properly and the way that they want, and also that their data are being protected as well. We also would see as I think some of the questions that were just being talked about, with the content of software business in the automotive market increasing substantially, that we have these assets and business opportunities that without these, there really won't be the engine to feed this software-defined vehicle ecosystem. And we need to protect the assets and business opportunities to enable the innovators to be able to fund their innovation. And I think the key message here is that if we do not have vehicle security, robust, adequate, comprehensive security, that a software-defined vehicle will not even be an option. We see three principles that are necessary to achieve the software-defined vehicle security requirements. The first is defense in depth. And I know that's, say, a commonplace that's been used for many years in other industries and computers and phones for providing security. And in cars, we are introducing these, and we have several layers of defense in depth that are available today. But with the increased connectivity and the increased authority that these systems will have in the vehicle, and also the increased complexity, that we see a significant increase in the number of layers of security that will be required to enable this. Security by design is also another key feature that I think for many automotive controllers, we've sort of designed cars, we put safety in, and then we are added security as an afterthought. I think for today's vehicles with the ISO SAE 21434, that it's OEMs and suppliers are being pushed or mandated, even if they were perhaps already doing it to some extent beforehand. Now we're being required to put security by design in during the development process, but the additional requirements we'll have for the software-defined vehicles will require substantially more. And then continuous risk management. I think with today's vehicles, the intrusion detection or anomaly detection systems are considered by some and maybe used in an initial phase, but for software-defined vehicles, I think this continuous risk management with anomaly detection on board is something that we will need to have in place in order to allow these systems to function in a safe manner. So when we look at our defense in depth, these new areas that are, I think, even outside of what we're thinking for when we see a car, that the plant infrastructure, the network, and the production line, that when we're building the vehicles and building the components that go into vehicles, security needs to be incorporated into that. When we look inside the vehicle, secure external communications and firewalls will need to be enhanced. New electrical architectures are required to support that. Secure in-vehicle communication, where we're doing message authentication for safety critical messages, and then putting security inside each ECU, or at least each critical ECU, where we would have dedicated hardware security modules offering protection for the individual components. And then when we begin seeing more of the operation for the vehicle and the personality of the vehicle being transferred out to the cloud or to a back end, that these secure network, identity, the endpoints, application, and secure data exchange back and forth, and the data at rest, that's, I think, a factor that we really haven't considered so much during the traditional security in the automotive environment today. I think the big focus today is inside the vehicle, and there's a bit of security when we talk with the back end, but the functionality of the vehicle is really tied inside the vehicle today. With the software-defined vehicle, you'll see more of the functionality being off the vehicle, or at least influenced by off the vehicle or connected off the vehicle, and that will require enhanced security measures. Within the automotive industry, we've been using V models for years to support ISO 26262 and functional safety requirements. And I think that this is something that we see coming more of a DevOps cycle rather than a you plan and then you verify and do the validation once, that it's something that'll be a continuous ongoing loop where we're designing, updating, testing, updating in the field, learning about how the system is working, improving it, and then continuing that cycle rather than a one-time pass through the V cycle. It'll be a continuous cycle. And I don't think that we have a good handle on the market today for how to fund the continuous development operation cycle. That's, I think, something that we're additional innovation in this area is required. And then as we connect this to the software-defined vehicle fleet, that we need to have an immune system. Part of it is maybe on board, where we're doing intrusion detection, monitoring, anomaly detection, and prevention on board on the vehicle, and then also off board in a VSOC center, where we would see the need for both of these, that the vehicle itself will have to do detection of anomalies, and then you would have a off-board system that's checking it, that's looking at the entire fleet to make sure that the fleet is being behaving as expected. And then software updates and monitoring management systems and firmware over-the-air updates, or FODA, that we would see these things as also, when we detect an issue, that we're able to update it quickly and then roll that update out to the fleet. So I think in summary, we would see the software-defined vehicle having challenges at all these different levels, with the increasing connectivity and complexity, and also the attack surface. We see additional requirements that security is becoming an even more important role, and without adequate security, that the software-defined vehicle will just be a non-starter. And then these three principles with defense in depth, enhanced security by design, and also a continuous risk management as critical factors that will need to be fleshed out in the industry in order to support that. I think that maybe on a simple perspective, that we see this as a fundamental transformation that probably bigger than the transformation from say no horse and buggy to cars, or from combustion engines to electric vehicles. That I think this smart vehicle, or the software-defined vehicle, is going to be an even bigger transformation than what these previous ones were. That smartphone on wheels is what we've heard people talking about, these software-defined vehicles, as with a lot of computation, a lot of interaction, and also a lot of connectivity with the outside world. And we see cybersecurity as the glue that will enable these changing vehicle architectures. And then maybe as a personal aside from just my work at the U of M in Dearborn, that I've been working on is trying to come up with security requirements that we would be using for real-time cyber physical systems that are different than what we would have in a laptop or cell phone. And some of these, or the three areas that I've been working on, would be self-attestation. So how can the individual controller in the vehicle verify that the software that's in there is the software that's supposed to be in there in a way that's compatible with the real-time functional safety, the limited capacity of the processor, and also the security goals, and find a solution that meets all of these criteria. And then the second one would be a remote attestation. So how can a buyer, autonomous vehicle user, or maybe a government regulator verify that the software inside the vehicle is correct without access to the original code? And I think that OEMs and suppliers are going to be reluctant to do a whole lot of this work that we were talking about with software, with multiple or orders of magnitude more money and effort and innovation invested into developing these, that it's not something that we can share easily. But then I think the end user and maybe the regulators, that they will want to be able to check and verify quickly that the software is in the vehicle is safe to use and it's the intended software without within a limited trust environment. And then the last one would be peer attestation. So if we have a software defined or a software module that maybe can float around from controller to controller, or maybe inside the vehicle to outside the vehicle, that how can one of these software modules be confident that its partners are all using the correct code? And then if it determines that there is something that's not in the state that it should, or that is compromised, how can it reach a secure state in a safe manner? So it's not enough to maybe just shut off if we detect something wrong, that the car is driving down the road and you can't just say turn off the steering system or turn off the braking system. That we need to be able to bring the car to a safe state without jeopardizing safety. So that was my quick overview for today. And if you have any questions, I'd be glad to field them or take my best shot at it.
Very good. Thank you very much, Robert. Very good overview, I think, of the challenges and the work that you're doing. When you look at the research that you've been doing, how far along are companies in their vehicle level cybersecurity development?
Yeah, I would say that there's a bit of a spectrum right now, that I think that all of the major OEMs and all of the startups that we're working with are taking security seriously and have started developing security concepts that are comprehensive for the vehicle and providing security requirements to the suppliers to support that, and in accordance to the way that we've defined in the ISO SAE 21434. So I think that all of the companies are following that. And then actually for Europe, if you want to sell a new car that's, let's say, a new type of vehicle that is getting its type approval in Europe after, I think, June or July of this year, that it's required to follow the ISO 21434 standard. And that, I think in Japan, it starts maybe in another year or year and a half. And then in Europe, for all new vehicles sold in Europe, will have to comply with that. So I think there's some government action. I know NHTSA just released maybe a week and a half ago their best practice guide for cybersecurity. So I would say that the implementation of it and the strategy for it, that's maybe a little bit different, and the pace that the different companies are looking at is varies a bit. But I think that there's a common consensus that security is essential. And also, if you want to sell a vehicle in Europe or Japan, that you'll have to follow the UNECE R155 to support that.
Yeah, that sounds like a very good way of helping support the implementation, isn't it?
Yeah.
What do you see as the main challenges that the companies are facing at vehicle level for cybersecurity?
I think that Probably one of the big challenges is sort of on the one hand, it's good, and on the other hand, it's maybe it provides a challenge, but that there really haven't been any, say, overt public malicious attacks on automobiles today. So and we don't really have a lot of data to go on to say these are the attacks that we need to protect against. And it's also a challenge that if you say, like my first vehicle that I released when I started at Bosch more than two decades ago, that I designed and released a braking controller, and that controller is still in use in a car that I just sold to my friend like 2 years ago. And it's the lifetime of these vehicles is very long, and for, say, a cell phone, you have to provide robust security for 2, 3, 4 years, and then it phases out, and then they can shut it off. But for a car, after 4 years, you're still paying for it if you've got a 5-year loan. So I think the lifetime is a significant challenge, and also the complexity, where if we put security into not just one module, but we have to put it into maybe 50 different ECUs. So it's a distributed cost that you need to do, and the complexity is significant.
Very good. Yeah, I think you're really touching on some of the big issues. Is corporate IT involved in this?
I would say, there was I'll stop sharing here so that it's looks better here, but I would say there was, at the Auto Isaac Summit just like a week and a half ago, there was a talk from someone that they had said that they see that a lot of the companies that are just starting or ramping up with security, they have product security on the one side and the IT security separated just from historical reasons. But as the companies get more mature, they see that meshing together. And I know within Bosch that we had the IT security and the product security were totally separated and never talked to each other. Then we moved them into the same building, and then we started to put it together so our governance structure, they have the same boss, and it's still, I wouldn't say that we're one single team working together all the time, but I think we're on that path where we'll see much more integration, and especially when you start to talk about devices that are using Ethernets and devices that are connected from your car to the outside world, that you need IT security and product security in that same product. So we see us merging more together in the future.
Yeah, it seems like a good point, because it seems like you're trying